downloaded. I'm going to try to go a little faster today. I don't know, no promises. All right, good morning, everyone. Today is Wednesday, November the 3rd. November the 3rd. All right, we got bell work. These two problems right here. These both look correct to me. So it shifts to the right 3 units, shift down 6 units, and the range, because this makes the whole thing flip upside down. So it's, oh, I thought we changed that. Okay, well, I would have sworn that oh, there's 2 of them. What's going on here? Hold on. I'm going to delete one of them. Let's see if I can do this again. 6. Okay, is it showing negative infinity to -6 now? I did change it, and it changed back. That was weird. Okay, so because of the negative symbol here, it causes the whole graph to flip upside down. So the range is actually negative infinity up to -6. Remember, the vertical shift determines basically where the asymptote is, where the horizontal asymptote is at. So it approaches -6, but doesn't actually quite get there. This one over here, we have a horizontal shift of to the left 4 and up 5, and this one has no flip. So this one is pretty straightforward. The range is from 5 to infinity. Remember, range is your y value, so vertical. So very good. All right, solving exponential equations. This should look familiar from Algebra 2 is my guess. So you got your paper, pencil, calculator. Make sure you have plenty of paper. And if you're someone that likes to take notes on their computer, you need to handwrite this stuff. And then you can transfer it to your computer later. All right, so reviewing properties of exponents. And again, this should all be reviewed from Algebra 1 and Algebra 2. All right, power to a power property. When you have a base to the m power raised to some other power. When I taught this way back in the day, I said pow, pow, multiply now. Kind of a fun rhyme. Pow, pow, multiply now. So we have a power to a power, so you multiply these. So m times n, power to a power. An example, 4 to the 3rd power raised to the x power. Well, power to a power, you multiply now. So 3 times x is 3x. Power of a product. So when you have some base A, some base B, and you multiply these together, multiplied by m. Well, we have choices. We can either multiply these together and then raise it to the m power, or what you can do is distribute this power to both bases. So it becomes a to the m times b to the m. An example, like 12 squared, I can rewrite as 3 times 4 to the 2nd power. And then I can distribute this 2 to both bases. So it becomes 3 squared times 4 squared. So that is the power of a product property. Negative exponent. Easy one. Whenever you have a negative exponent, all you do is you flip it. So if it was in the numerator, it goes to the denominator. For example, 1 over 2. Well, remember that 2 has an invisible 1 exponent. If I want to move this to the numerator, I just have to flip the sign of the exponent. So that invisible 1 becomes a -1, and we get 1 times 2 to the -1 on top, which is just 2 to the -1. This property seems to be forgotten a lot of times. I don't know why. Maybe because we don't use it a whole lot in math. At least not until now. The next property we have is the rational exponents and radicals property. Hopefully all of you remember this, but whenever you have a radical like we have here, this variable m, this is called the index. So if this was invisible, it would be like it is over here. If it's the index is a 2. So when it's not there, it's always a 2. But it could be like a 3 or a 4, like cube root, 4th root. So the m root of a to the n power is equal to, well, that index, you can stick it back inside under as the denominator of the exponent. And that's why you see it a raised to the n over m power. So for example, this radical 7, there's an invisible 2 right here. And there's an invisible 1, remember 7 to the first power. So this 2 gets stuck with the exponent and the denominator of the 7. So that's why it's 7 to the 1/2 power. All of these look familiar, correct? All right. All right, exponential equations. An equation where the variable is in the exponent. So for example, we have 5 to the x power equals 5 to the 4th. All right, to solve, get both sides to be the same base. Well, in this case, they are already the same base. So the base being the 5 and the 5. So the base is the 5, the exponent is the x. The base is the 5, the exponent is the 4. So when you're solving problems like this, you have variables in the exponent. Your goal should try to be to get the bases to be the same. Well, when the bases are the same, all we got to do is now, if the bases are the same, like it says here, you set the exponents equal to each other. So I would say x equals 4, and then we would solve. And for this very simple case, well, it's already done for us. It's very clear to see that x is, well, equal to 4 even before even doing anything, but that's how you do it. It should also look very familiar. All right. So let's do one together. And I have lots of examples. So we were on slide 7 of 23. I have lots of examples I want to get through. All right. So class, tell me, how can we approach this problem here? Hello? Doing the negative exponents rule and going backwards. Well, no, that wouldn't really help us because it would just make it 1 over 16 to the x power. Remember, let's go back to this page. Remember, our goal here is to get both sides to have the same base. That's what we're trying to do. Are these bases the same? No. Yeah, so let's try to make them the same. How can I rewrite 16? Yeah, so 4 times 4, in other words, 4 squared, right? I could rewrite 16 as 4 squared. So let's do that. So I'm going to have 4 squared, and then don't forget we have this negative x, so we just multiply them together. How can I write 64? 64 is 4 cubed. It sure is, so 4 cubed. Does everyone see how we did that? Okay. So once the bases are the same, we set the exponents equal to each other. So the exponents would be these guys right here. So we'll say 2 times negative x equals 3. And I'm going to go ahead and multiply that 2 times negative x the same time I set them equal to each other. So 2 times negative x is negative 2x. And then let's solve. So we divide both sides by negative 2. And x equals negative 3/2. And if we were to replace this x with negative 3/2, it would equal 64. And you can go ahead and type it in if you want to. Type in 16 raised to negative parentheses, negative 3 halves, and hit enter, and you will get 64. And that's how you can verify your answer. Does doing this look familiar from Algebra 2 or Algebra 1? I hope it does. I think the problems we're going to have in this class are going to be a little harder. We're starting off easy, though. All right. Ideas for this one. Ideas. There's a couple things that I can think of. How about you? Make the 81 an exponent. Okay, let's do that first. We have, oops, that's my pointer, not my pen. So we have 9 squared. Okay. So now we have 1 over 9 as this base and 9 as this base. We're getting close because we have 9 and 9, but one's 1 over 9 and one's a 9. So any other ideas? I think we're on the right path. Any ideas? I wish I could see like your faces as you're thinking, because I don't even know if you're asleep or not. I'm drawing a blank. Yeah, okay, that's fair enough. Use the negative exponent rule to make 1 over 9 9 to the negative 1 power. So Naomi, that is I think is a very good idea. Yeah, there we go. Yeah, so let's do that. I'm going to actually do this problem two ways. I'm going to do the way that both of you said, is we're going to take that 1 over 9 and we're going to rewrite it as 9 to the negative 1 power, right? Because it's the inverse. We can just flip it, right? And then don't forget, the exponent is already n plus 3. So we just kind of just carry that with it, and we have to multiply them. And then on the right side, we have 9 squared. Okay. Does that look right? Yeah. All right. Everyone solve for n very quickly. I'm going to do the same thing. Bases are the same, so we set the exponents equal to each other. That look right to you? Is n equal 1? No, that can't be right. I messed up somewhere. Hold on. Yeah, I can't do math, apparently. Hold on, let me back up. There we go. Yeah, apparently 2 plus 3 is not 1 or negative 1. I knew I messed up somewhere. Okay, there we go. N equals negative 5. Okay. That looks better. Basic math is hard sometimes, especially when the numbers are less than 5. I promise you, I know how to do math. All right, so that's one way to do it. Another way that we could have done it is rather than flip this to make it a negative 1 power here, we could have actually flipped this 9 squared. So let me show you that. So we're going to have, on the left side, we're going to have 1 over 9 raised to the n plus 3. And then we're going to flip this guy to be 1 over 9 raised to the negative 2 power. All right, does everyone see that? Because 1 over 9 raised to negative 2 is still, if you type that in, hit enter, it will still be 81. Now, there are a couple steps that I kind of skipped to go right to this, but they're all really boring steps, and I probably should have put 1 and then put a 9 to the negative 2 power, and then 1 raised to anything is always going to be 1. So I have like a common negative 2 and negative 2 power, and I could have pulled it out. Yeah, there's a couple things that I kind of skipped over, but this is still equal to 81. All right, next we are going to, oh yeah, I have to write it over here. So I get 1 over 9. Oops, that's my pointer. Get 1 over 9 raised to the negative 2 power. The bases are the same, so we're going to set the exponents equal to each other. So we get n plus 3 equals negative 2. Subtract 3 both sides, and hey, look at that. It's weird. We get the same answer. What a coincidence, right? But most of the time, I think flipping numbers to become fractions seems kind of strange. Just feels weird doing that. So most people, I think, would have chosen this route, and honestly, I probably would have chosen that route too. Yeah, I probably would have done it this way too, but I did want to show it. It can be done 2 ways, and maybe even another way. I don't know. Okay, everyone, try this problem. Let me give you all my phone in my pocket. Let's say 2.5 minutes to do this problem. All right, ready, go. All right, whatever one get for the answer. All right, lost. Okay, well, let's start here. What did you try to make these bases become? 4. Okay, so let me ask you this. Can you have 4 to some power equal 32? Let's think about it. So 4 to the first is 4. 4 squared is 16. 4 cubed is 64. So there's a problem. So when that happens, 4 is not the choice that we want to use. So what's something else that we could use instead of 4? 2. Yeah. So let's start with the 4. 2 to what power equals 4? 2 to what power equals 4? Yeah, 2 squared. We're going to have, oops, hit the wrong button. 2 squared equals 4. And then don't forget, we already have that negative p minus 3 already up there. We have to multiply them. All right. And then I saw Naomi put 2 to the 5th power equals 32. And don't forget, we already have the 3p up there to multiply together. All right. The problem just got super easy, right? All right. So does anybody have an answer for what n, or not n, what p equals? Because it's early and you haven't had your breakfast yet. Remember, your brain's fuel is glucose, and when you wake up in the morning, your glucose is probably kind of low because you were sleeping. So have like a glass of orange juice, some fruit, some breakfast to bring up your glucose up, and your brain will function better. I always try to have at least a glass of orange juice in the morning. So you drink a health drink. Well, so health drinks don't necessarily have like natural sugars. So those health drinks may take a little bit of time to convert into glucose. Science. Yeah, healthy's no fun. All right, -6/17. Anybody else agree with that? I actually have no idea what the answer is. I don't. Yeah, I don't have any of these worked out. So bases are the same. Let's quickly do it. Negative 2p minus 6 equals 15p. I'm going to add 2p to both sides. And the reason why I did that is because I wanted to keep my p positive, and it looked like I would have to perform less steps. So it looks like -6/17 is equal to p. And yeah, that's what Lonnie got too. I agree. Yeah. Fun stuff, right? Hold on. Let's find a harder problem. Those are too easy. Let's do this one. Let's do this. Oh boy. Anybody think they might have a way to start this problem? And the more you do these, the easier it is to kind of recognize what we need to do. Like when I look at these, it takes me maybe a half a second to realize what we should do. And these just take practice. And I have probably 20 years of practice on all of you. All right, so we probably want to. Well, we have a 5 here. We have a 5 here. So our goal is probably to make the bases become a 5. Did anybody think of at least that? Not necessarily how to do it, but the fact that we probably need the bases to be a 5. Yeah. Okay. So let's make them a 5. Now, so we're going to use that radical property, whatever it's called, the index. I don't remember what it's called. Whatever property that was. So that square root of 5, I can rewrite that as 5 to what power? 5 to what power? And if you had your guided notes printed out in front of you, you can just kind of flip back to those pages if you didn't write it down. Yeah, 5 to the 1/2 power. So that becomes 5 to the 1/2 power. If that was a cube root of 5, it would be 5 to the 1/3 power. If that was a fourth root of 5, it'd be 5 to the 1/4 power. And don't forget, we already have the exponent of x plus 2. So don't forget, we're just going to multiply that 1/2 times, well, what's already there. Okay, how can I rewrite 1 over 5 to be a 5 as the base? So remember that 5 has a 1 exponent. It doesn't have a 5 exponent, it has a 1 exponent. Yeah, so we bring it to the top, it becomes 5 to the negative 1. Yeah, so really what's going on, we move this to the numerator to become 5 to the negative 1 power, and then that 1 is still there, and there's a 1 in front, so it can be 1 times this, and 1 times anything is going to be that, and that's why we don't include that 1 with it, because, well, 1 times anything is, well, whatever we multiply by. And don't forget, we already have an exponent, which is 4 to the x, so you have to multiply that negative 1 times 4 to the x power. All right, the problem got super easy, right? All right, everyone, quickly finish this problem. Tell me what you get for x. Don't bend me, boy. What you doing? What you doing? All right, what do we get? What do we get? Does x equal negative 10/3? Anybody? I should probably have these worked out so we can actually have the answers, you know? Oh, actually, I'm going to do something more fun. So you agree. So I'm guessing everyone here probably distributed this 1/2 to both terms, right? So you had 1/2 x plus 1 equals negative 4x, right? Yeah. So watch this cool trick I'm going to do. Rather than distribute this 1/2 is I'm going to, well, of course, set these equal to each other, the exponents, but I'm going to multiply both sides by a 2 to clear the fractions. So we're still going to have, we're going to have equals. So that's going to be negative 4x. But instead of distribute that 1/2, and I'll just go ahead and rewrite it just for completeness. Multiply both sides by 2 to get x plus 2 equals negative 8x. And then I'm going to add 8x to both sides. So I get 9x, and then I'm going to subtract 2 both sides, and then divide both sides by 9. And, hopefully what I did makes sense. Negative 2/9. All right, so I see a few of you agreed with negative 10/3. Did I make a mistake? You distributed the negative 1 to the x. So let me do it that way, just to show we can do it both ways. So distribute the 1/2. So we get 1/2 x plus 1 equals -1 times 4x is -4x. And then we're going to add 1/2 to both sides. So actually, I'm gonna add 4x to both sides and then subtract 1. So 1/2 plus 4x. So 1/2 plus 4 is 5/2. Is that right? Hold on. No. 9/2. Right? 9/2. I don't know. Math is hard right now. Is 1/2 plus 4 9/2? I think it is. So I'm adding 1/2 plus 4 is 9/2, right? And then subtracting 1 both sides. Okay. And then multiply both sides by 2/9 to clear the fraction on the left. So we get x equals, and then -1 times 2/9 is -2/9. So same answer, right? Yep, same answer. So I showed it both ways. Doing it this way, distributing that 1/2 is totally fine, right? As long as you know how to deal with fractions like this, yeah, right. Or if you saw, hey, I can clear the fractions by, well, first dealing with this and then multiplying both sides by 2, and now we don't have fractions, and it's pretty easy. So either way, right? Math. There's so many ways to approach certain problems. Sometimes there is only one way to do a problem. Um, but I would say not most of the time. A lot of times there is more than one way. It's kind of how you see it. But guys, for today's lesson, the hardest part of this should be getting the bases the same. After the bases are the same, solving solving for x or whatever variable it is, this should be super simple. If you're getting tripped up on this stuff, I don't know. We got to figure out what you're thinking, where the mistakes are, and kind of correct it. And the more we do, the more you see, and you can make those corrections and not do them in the future. All right, so we have the fourth root of 4 to the -8x equals 2 to the 10. All right, so here's the hint. The base is a 2 here. We want to make this side have a base of 2 as well. And I know it's a 2 because, well, 2 is a prime number. We can't rewrite 2 anywhere else other than 2. Well, that's not entirely true. I could rewrite 2 to the 10th as many different numbers. But anyway, all right. So this is the fourth root of 4 raised to the -8x power. How can I rewrite this radical as some number raised to a power? So let's start there. How can I rewrite as 4 raised to some power? And flip back to the notes on the power properties. Yes, 4 to the 1/4 power. Yep, 4 to the 1/4 power. And I'm going to just put the 4 on the bottom, but it is 4 to the 1/4. And because we have this already as the exponent, that is the numerator. So we have -8x. All right, does everyone see that? So you just take the index and stick it in the denominator of the power that's made already be there. And if there's no power there, I'm just like Naomi says, it'll just become 4 to the 1/4. And we need to simplify. Can I reduce this fraction, this -8/4? Can I reduce this at all? Yeah, what does it become? Yeah, it becomes just -2. Okay, now that's simplified. Now let's. I saw one of you in chat already say what to do this for. So I can rewrite this 4 as 2 squared. And then we already have the exponent of -2x. So we're just going to multiply the 2 times the -2x. And then I might as well just carry down this right side. Now we could have dealt with this 4 at the beginning and done 2 squared times -8x to get -16x. So just off to the side, we could have rewritten that as 2 squared, and so 2 times -8x is -16x. And then we have the fourth root of that, and then we could have written this as 2 to the -16x over 4, and then 16 divided by 4 gives us 4. And look, we get the same thing, right? 2 to the -4x. Same thing. So different ways, depending on how you want to deal with it. So let's set the bases are the same, 2 and 2. So we're going to say the exponents equal to each other. So 2 times -2x is -4x equals 10. And then let's quickly just solve the rest of it. So divide both sides by -4. And let me just. Sometimes I show what I'm doing. Sometimes, most of the time, I don't. I just say it. But and let's reduce that 10 over 4. So 2 goes into 10 5 times, 2 goes into 4 twice. So that's what you get. -5/2. Yep. So we got to use those properties that we learned, or that when I say learned, I mean reviewed, because none of this should be new. You just probably forgot it, right? We use these properties to get the bases to become the same. More properties. Hey, how much time we got? Okay, 15 minutes. So guys, I am going kind of fast because I do want to expose you to a lot of these problems. So I totally understand. There are a few of you that probably can't solve these as fast as we're going, and that's okay. You can always watch the recording later, work on these problems after the fact. Zero exponents. So anything to the 0 power is equal to 1. And of course, for this to be true, your base can't be 0. So 0 to the 0 power doesn't equal 1. So anything to the 0 power other than 0 is equal to 1. That's important to know. And then whenever you multiply and you have same bases, you add exponents. So be careful. So like, for example, over here, we have 5 to the 3x times 5 to the -2. This is not power to a power multiply. This is same base. Same base, you add the exponents. So this times this, same bases, we have 3x plus -2 is 3x minus 2. So you add exponents. For whatever reason, people mix those properties up, and you have a bad habit of multiplying these exponents together instead of adding them. So same base, multiplying, you add the exponents. So that's why I like the whole pow multiply now. That is the only time you multiply exponents. Power to a power. Multiply now. And then here's another one. 2 to the 0 is equal to 1. Pi to the 0 power equal to 1. Let's apply those. All right, multiplying. All right, multiplying. What do we got to do? Yeah, we got to turn that 4 into 2 squared first. Yeah, so in order to add the exponents, the bases need to match. Well, so we got to turn this 4 into a 2. So let's do that. We're going to have 2 cubed times 2 squared, and then times negative k, right? And then 64. Let's go ahead and make that a 2 as at the same time. Might as well, right? 2 to what power is 64? 2 to the 6th power? Okay. All right, so then now let's, on the left side, now we can add those exponents. So what do we get on the left side? 2 to what power? 2 to what power? Two. So just to get picky on your text input, whenever you do 2 to raise to that power, you have to put it in parentheses like that, because without it, it looks like you're doing 2 cubed and then minus 2k as a base afterwards. Just being picky, because that is what it's supposed to be. I know. Guys, if I don't correct you, how will you know? How will you know? How will you know? Someone's got to correct you. All right. So, yeah. So we're going to have 3 minus 2k, or we can just write it in standard form and put the negative 2k first. It doesn't matter. I'm just going to leave it as 3 minus 2k. But standard form, you should have negative 2k, then plus 3, but it doesn't matter. All right. And then on the other one, 6 times negative 3k is negative 18k. And then from here, we can quickly solve it, right? We set them equal to each other and we solve. So I'm just going to quickly do that just to show the final answer. But all of you can do this just fine. So I'm going to move everything to the left side to make my case positive, but we could have just moved that negative 2k to the right and then divided by negative 16, I think. So 18, 16. So I get 16k on the left, and then I'm going to subtract 3 both sides. And then I divide by 16. And that is simplified. Can't reduce it any further. Looks good? Do you agree with my answers? Remember, I don't have the answers, so I make all kinds of mistakes all the time, especially when I talk. When I talk and write, I'm a very bad multitasker. All right, let's see what we got here. What time we got? We got 9 minutes. Let me just kind of flip through some of these questions. I want to see what we have. All right. Do I have the answer key to these? Let me see. Oh, I do. Okay, so the last 4 problems, I do have the answers for them. So I won't do those. I'll leave those up to you to work on your own time. But we will do this one, and this one. So let's try to do 3 more before in 9 minutes. Be kind of difficult. All right. So looking at everything, we got this 1/2 to this power, 16 to this power, and 1/8. What do you think our ultimate, our base is going to get down to? what number should the base be? What do you think? Yeah, probably a 2. Yeah, I agree. It is probably a 2. Partly because this one's already a 2, and I can't really make it anything more than that. At least not really. So let's try to make everything. Let's try to make this a 2. Let's make that a 2. Let's make this not a fraction anymore. All right. So see, this is a negative already. All I got to do is flip it and make it positive. Let me show you. And on the side, I'll show you the work of why that works. So this becomes 2, and then that negative power becomes a positive power. So again, I did take some shortcuts to get there, but let me show you what exactly is going on. So remember, there's a 1 right here. So when we bring that to the top, we get 2 to the negative 1 power, right? So 1/2 becomes 2 to the negative 1. And then we have the negative 3v on the outside for the exponent. And remember, this is pow pow multiply now. So we multiply these two together to get a positive. So negative 1 times negative 3v gives us positive 3v. So yeah, so that's the work that I skipped to go right here. Just because whenever you inverse a fraction, you just change the exponent from one to the other. In this case, it's negative; it becomes positive. It's really that easy. And then again, here's the work to show what I did. This times this is this. Hopefully that makes sense. All right, 16. 16. So 2 to what power is 16? Yeah, 2 to the 2, 4, 8, 16. So 2 to the fourth, right? Yeah, 2 to the fourth. And then we already have the negative 3v minus 2. And then 1/8. Um, I can make this, I can make 1/8 equals 1 over 2 to the third power, right? Is that 8? Is 2 cubed 8? It is, right? Yeah. So then I can flip it and bring that 2 to the third to the top and make it a negative 3. So does that look good? All right. And then what does the left side become? And actually, before that, let me simplify some stuff, as it looks like I probably should. Okay. Now, what should it become? 2 to what? Yeah, 2 to the negative 9v minus 8. So same bases, 2 and 2, you add the exponents. So this times this, same bases, add the exponents. So 3v plus negative 12v minus 8. So we have 3v minus 12v is negative 9v. We're just combining like terms at this point. And then we just have that minus 8. Okay. Now it looks kind of simple, right? We just set the exponents equal to each other, and then we solve. We get negative 9v minus 8 equals negative 3. We'll just add 8 to both sides. 8, 765. And then divide everything by negative 9. So v equals negative 5/9. Does that look right to everyone? Does my math make sense? Let's see. We got two more. Let's do that. This one looks harder. This one looks super, super easy. Um, Everyone do this one. Let's do 2.5 minutes, see what you can do. Ready, go. Okay, so what did everyone make their bases become? So what's the base on both sides? So everyone chose a 4. Did anybody choose a 2? Anybody? So 4 works, 2 also works. So if you made them all to become a 4, good. If you made them all become a 2, also good. It doesn't matter. All right, anybody have an answer for this one? N equals negative 4/3. Yeah, maybe. Let's find out. Let's find out. All right, so we get 64. That one becomes, what is that, 4 cubed? And then that 16 is 4 squared, which becomes 4 to the negative 2. All right, so we got we basically get 3 plus 6n plus 3 equals negative 2. 3 plus 3 is 6. Subtract 6 both sides. and then divide by 6. 2, 4, 6, 8, 2, 4, 6. Yeah, negative 4/3 is what I got. Good. Easy peasy. All right, there was, so let me quickly just run through this one just to get the answer. I am 2 minutes over though, but sounds just like me, right? All right, 36, 6 squared. Yeah, this one's really easy. Yeah, negative 2/3. Something I didn't mess up. Too easy. All right, guys. So there are 4 more problems, and hopefully you all downloaded the PDF file, the guided notes, and you have them. So you have all 4 questions, and you also have the answer key to all 4 of them. So I strongly recommend working all of these out and then checking the answer. And then, of course, doing the learn and practice modules, doing those examples, and checking those answers as well. Remember, guys, to be successful in this class or any math class, you need to practice. And if you're done with math after seeing the live lesson, you're doing it wrong and you're just hurting yourself. All right, everyone. Well, as always, thanks for coming, and I hope you learned something. I will see all of you tomorrow. All right, everyone, have a great rest of your Wednesday.